Hey guys, how's it going? How you doing? Thank you so much for hitting the play button. Turn that up. Appreciate you being here. Let's go. Just need to quickly check to make sure things are working. Just quickly, briefly. Thank you so much for hitting the play button. There we go. Good. Awesome awesome. How you doing? Thank you for being here. Let's get into this. We're gonna be working on some mathematics stuff, changing things up, guys. For myself, just keeping things interesting. I tend to get when I work on something for way too long, and I'm talking like months, not couple hours. I'm talking months working on something. Months and months and months and years. Either way, you get the idea. I tend to get bored. It's kind of like challenge complete, and it just feels like it gets easier. So, but I'm not trying to think that way. I am trying to, of course, I'm remaining positive. I like changing things up. Of course, I'm a technical guy and a math major, I guess, if you will. Now, not to get into anything, I'm just going to kind of, in regards to schooling and college, I certainly hope that your instructor is teaching you the course or the program and nothing more. That's the way it should be, guys. I probably should have titled this for homeschool. A lot of parents are homeschooling nowadays. Support you in that. Hopefully, that's why I'm doing this, guys. It's for you parents, homeschooling. If you need any additional help and support, I understand why you have made that decision, and that is great. That is fine. So hopefully I'm here to help. I can help you guys, help your child grow. And we're just going to talk about the subject. I have to remind myself as well. I tend to get on a tangent sometimes, but I don't talk, that bad word that starts with, well, yeah. Hopefully you understand what I'm getting at, but we're gonna stay on topic. We're gonna talk about mathematics, and let's help your children's learn and grow. Let's go. I support you. Okay, so we're gonna get into this. We're gonna begin with I kind of have a I guess maybe you could technically this is the wrong one here, and I'm on the wrong part. This is what we're gonna do. Eventually we're gonna kind of be going through this. I scanned this today. We're just gonna go over some key terms. It's mathematics, but it's basic life stuff as well, guys, right? Things that we know of in life and just like to have a better understanding, right? Because, that's why we have mathematicians and scientists and stuff, right? When things are created, words or concepts or topics, it's a group of individuals that get together, they do their scientific experiments and such, and together, collectively, they make a decision and say, this is yes. And they all have to agree upon it, right? It's not just one person, one opinionated or over-opinionated person spreading their thoughts to the world and going, okay, this is how it is. No, it's not. It's a group of people collectively. Okay? And for example, like mass and weight and that, right? They all work together and they determine the definition of mass and what else not, right? Final answer. That's what these are. So let's go over this. Just kind of I don't know, it could be a refresher. It doesn't hurt to kind of just talk about it, get a refresher, and then update. What is mass? What does mass mean to us? Okay, I don't really have any images. I have Wikipedia up. I guess I could share this, right? I'm going to share Wikipedia. It's a great source. Okay, this is kind of I guess, an image for you. Okay. Mass is an intrinsic property of a body. Okay. It was traditionally believed to be related to the quantity of matter in a body until the discovery of the atom and particle physics. It's awesome. I love chemistry stuff too, as well. Okay, so it was found that different atoms and different elementary particles, theoretically with the same amount of matter, have nonetheless different masses, right? Mass in modern physics, right? Like Newton's laws, the apple dropping on his head, we all know what gravity is, right? Keeps us on Earth. Okay, mass in modern physics has multiple definitions which are conceptually distinct but physically equivalent. Mass can be experimentally defined as a measure of the body's inertia. Okay, inertia, like if you think you understand what friction is, right? There's a certain amount of force required to make an object move, right? An object having mass, right? So it kind of like inertia is kind of in there too, right? It's kind of like the stubbornness to move, if that makes sense, right? Meaning the resistance to accelerate, change of velocity when a net force is applied. Okay? Think of inertia as the stubbornness to move. That's based on your mass, right? The object's mass also determines the strength of the gravitational attraction to other bodies. Okay? Wikipedia has a lot of good information. We won't really get into this. Well, I guess I'll quickly read this. The SI base unit of mass is the kilogram. Okay, I know a lot of you awesome imperial people. I grew up on the imperial system before I learned the metric system. So imperial for me was first. And I'm up north. Okay? So you kind of have to learn the metric system a little bit and understand the conversions between the two. So we'll get into that in the future. In physics, mass is not the same as weight, right? So guys, so take note of that in your head, right? Mass is not the same as weight. I know a lot of us in our minds, we like to correlate them together in a singular group, I guess, and think of them as the same. It's not true. Think of mass as your molecular density, the makeup of your body. Weight is calculated based on gravity. So your mass multiplied by gravity equals weight. Okay? And yes. Okay? So, even though mass is often determined by measuring the object's weight using a spring scale or whatever, a balance scale, comparing it directly with known masses, right? You obviously have to be 100% certain of a certain object's weight or mass to be able to do these types of experiments, right? An object on the moon would weigh less than it does on Earth, right? Because with the moon's gravity, let's just bring it up quickly, okay? Most of you know what the gravity on Earth is. Let's go gravity on the moon. Okay, gravity on the moon is 1.62. Okay, I'll just kind of write this down. I'm gonna kind of use this for as kind of writing on, guys. Hopefully you don't mind. Let's just go moon. I'm gonna do my best. I mean, I don't have a tablet, guys. You know, hopefully, you know, maybe the channel would grow 1 year and I could buy stuff like this. But I'm actually using my mouse. Okay. I would write it all out, and that's per second squared. Okay, and of course Earth. I'm trying to write it kind of nicely so that it's legible. So the more I do this, the better I'm gonna get at it, and that's 9.81 meters. I've got that memorized, so I could look it up, but I know that's what it is. Okay, quite a bit of a difference, right? So if you obviously multiply your mass times the moon, it's going to be a lower value in comparison to multiplying your mass times Earth's gravity. Okay, I might have to stretch out these videos a little longer, but, well, not longer. I'm going to keep them short, guys, but we might have to continue this to the next video. All right, just letting you know. So let's finish up quickly. So an object on the moon would weigh less than it does on Earth because of the lower gravity. It would still have the same mass, right? Mass does not change unless you start, you know, I'm not suggesting or recommending you do or anybody do this, but if you start like trimming off parts of yourself, I guess you would change your mass, but you don't want to do that, right? That's not good. No. Let's not be doing that, guys. Okay? Keep yourself together. All right, so your mass is like a constant. Of course, as you grow and you change and your body grows and gets taller or whatever, that's going to change, right? But your mass is still your mass. Again, think of it as the molecular structure of your body. Okay? So this is because weight is a force, right? So you can correlate weight and force together because force equals mass times gravity and weight equals mass times gravity. It's all the same, guys. Okay, so mass is the property that, along with gravity, determines the strength of this force. Okay, all right. So I'll just close this. I have something else more I'll read. What is mass? Why are feathers lighter than bricks? I'm just going to write gravity here so anybody reading it, I'm trying my best to write here, guys. It's not too bad considering gravity. Okay. Why are feathers lighter than bricks? Well, molecular structure again. Mass is this case. So I'm reading from, this is an article done by Andrew Zimmerman Jones, okay, back in March 28th, 2019. Now, it's all the same, nothing changes. The scientists that have collectively made the decisions on what the definition of mass and weight is, that's the same. It's unchanged, right? So, okay, mass is a scientific term used to describe the density and the type of atoms in any given object, right? If you study chemistry or whatever, you'll learn about atoms and molecules, okay? Just because you can't see them with your own naked eyes does not mean they don't exist. They do exist. Okay? The SI unit of mass is the kilogram. I don't know why, is that supposed to be a global value? I don't know why it is. I mean, pounds would be another one, but anyways. The mass can also be measured in pounds. Hey, there we go. They included it. To quickly understand the concept of mass, think of a pillowcase filled with feathers and a similar pillowcase filled with bricks. Okay, which has a greater mass? It's quite obvious, right? So, because the atoms in the bricks are heavier and denser, right? Density, denser, you understand, right? Hopefully. The bricks have a greater mass. Thus, it's at a molecular level, guys, okay? When they're talking about denser and density. Okay, so thus, even though the pillowcases are the same size and both are filled to the same degree, one has much greater mass than the other. Okay, that's like, common sense stuff, right, guys? You're all smart, beautiful, intelligent people. You understand this. Those that contradict that or say otherwise, issues, problems. Okay, scientific definition of mass. Mass is the quantity of inertia, resistance to acceleration, right? It's almost like something that doesn't want to be pushed around, right? Possessed by an object, or the proportion between force and acceleration, referred to in Newton's second law of motion. Now, if I click the link, is that going to bring it up? Newton's second law of motion. Stay tuned. We're going to actually get into that. We're not going to go over it right now. Boy, that's why I'm not sharing this one page, because it's got so many pop-ups and yeah. I don't want you guys getting distracted. So apologies that the screen is that, but it's okay. We don't want the distractions. Okay, let's focus, right? Focus and learn, guys. All right. Okay, Newton's second law of motion. Force equals mass times acceleration. That's the second law, okay? Same thing with weight equals mass times gravity. Acceleration, gravity, all the same. Because acceleration is also meters per second squared, guys. Okay? So you can correlate acceleration with gravity. Essentially, when you're falling, you're accelerating, right? In other words, the more mass an object has, the more force it takes to get it moving, right? Larger objects are going to require more force to move, right? Versus a pebble. In most common instances, mass is determined by weighing the object and using the force of gravity to calculate the value automatically. In other words, in most real-world situations, mass is the same thing as weight. See? I don't like what he said there, because, that's going to just confuse people, right? So, kind of ignore that statement. Weight, again, weight is directly proportional to mass times gravity or acceleration, either way. Okay? Let's not confuse the two. They're not the same. In the example of the feathers and the bricks, the difference in mass can be described by the relative weight of the two pillowcases. Obviously, it takes a lot more work to move a bag of bricks than it does to move a bag of feathers. But weight and mass are not really the same thing. There we go. I'm glad he corrected that. Okay? Because of the relationship between weight and mass, these concepts are frequently confused, right? Just like we were talking about. So, right? So separate the two concepts in your mind, right? Again, weight, you have to multiply it by acceleration or gravity. That's how you get weight. It's as simple as that. Okay, so you can in fact convert exactly between weight and mass on the Earth's surface, but that's because we live on planet Earth. And while we are on this planet, gravity is always the same, right? That's unchanged. That's a constant as well, guys. Okay? Unchanged. Okay, so if you were to leave the Earth and go into orbit, you would weigh almost nothing. You would feel like you're floating. Like, I don't know if you guys have parachuted or whatever. I mean, if you do or have, oh, that's super awesome. You wouldn't really feel weightless falling, right? I know what it feels like to fall. I've jumped and stuff before. So, but in space and that, you would feel like weightless. You really would. Okay, now not that I know about that, but I could visualize that. I could actually, actually understand and visualize that. I don't know, it's just a logical thinking thing, I guess. I don't know how to explain it. So, yet your mass defined by the density and type of atoms in your body would remain the same, right, guys? Mass, that's unchanged. Your mass does not change. I mean, and technically speaking, as you go from a little child to an adult, it's going to change. But every day it's always going to be a constant, right? Until you stop growing and whatever else. So, if you landed on the moon with your scale and weighed yourself there, you'd weigh more than you weighed in space, but less than you weighed on Earth. If you continue your journey to the surface of Jupiter, I guess I could bring up, now that we talked about it, Jupiter. Let's bring that up quickly. Woo! Oh, wow, that's crazy. Didn't mean to get all excited there, guys, but check this out. Okay, so Jupiter. Check this out. I'm trying to write it as nice as possible. Okay? Well, huge difference, right? So you multiply your mass by Jupiter's gravitational force, you're going to feel so heavy. Like, when you live on Earth, you get used to gravity, the force of gravity upon you, right? You get used to it, accustomed to it, right? So, but if you go to like another planet, now I know I'm not saying that I understand this. It's obvious I don't, but I can understand that it would feel like you're being squished. I would imagine like you're being compressed. You would feel so much heavier. You would feel like you have, I don't know, boulders in your pants. I don't know how else to explain it, but that would be a lot. You would feel really heavy. It would be super hard to walk, right? Because we're not used to that, right? So I have to finish up here, guys, because I got to get out of here. But I'm going to go 24.79 divided by 9.81. That's 2.5 times the difference compared to Earth. So you would weigh 2.5 times heavier. So let's say you weighed 120 pounds. I'd multiply that by 120. You would feel 300 pounds on Jupiter. So do you understand the difference? It's huge. Imagine you're used to your mass, your weight on Earth. You're like, I'm 120 pounds. I'm not 120 pounds. I'm a lot heavier than that. But I'm still healthy and in shape to a degree. But anyways, you would go from like feeling 120 pounds, we'll say a lady, smaller lady, to feeling like 300 pounds on another planet. It would be crazy. So I don't think you would want to live there. Maybe we'll talk about the gravity on Mars. But I have to finish up. So hopefully I remind myself to talk about that. So if you landed on the moon with your scale and weighed yourself there, you'd weigh more than you weighed in space, but less in blah, blah, blah. So if you continued your journey to the surface of Jupiter, you'd weigh a great deal more. If you weighed 100 pounds on Earth, you'd weigh 16 pounds on the moon and 37.7 pounds on Mars. So they already figured out Mars. Obviously, Mars is more than the moon. 100 times. No. So Mars. Okay, since we're already here, I wanna do Mars quickly. I'm not gonna write it out. Mars is 3.73, so it's like at 1/3 of the Earth. So you would feel a lot lighter. It'd be a huge difference. You might even feel lightheaded. I don't know. But a human would have to get used to living on Mars if they actually lived on Mars, because that's a huge transition, guys. You would feel 1/3 lighter. You would feel like you lost 1/3 of your weight or your mass. So you would actually, as a human, have to get used to that. It would be a weird feeling, I imagine. Okay, so that is it. I'm going to leave it at that. I got to bounce. Hopefully you enjoyed listening to me talk about that. And hopefully it helped you out. Stay tuned. We'll do some more, guys, based on views. Hopefully, it helps you guys. I'm trying to be a learning channel, right? Bear with me. I get a little frustrated because it's like, it seems like I should stay off topic. I really should. It just feels like the dumber it is, the more popular it is. I wish it was the other way around. Wish you all the best. Whoever you are watching, whether you're a student or a parent hanging out with your child, learning together, support you all in this endeavor. Hopefully I can help you guys out. So yeah, thank you for being here. I'm gonna stop and I'll see you guys in the next video. Take care, guys.